Students, we will discuss today some important questions and which are appeared in previous entrance exams. Students, we will discuss some expected questions from S block elements, the first A group and second A group, alkali metals and alkaline earth metals. Let us see the question number 1. Which statement is false for alkali metal? Option 1, lithium is strongest reducing agent. Yes, it's well known to you, and lithium among the first A group of elements, it is strong reducing agent. Coming to second, sodium is amphoteric nature is given, but sodium is actually alkali metal. Given as what sodium is amphoteric in nature? No. Coming to third, lithium plus is exceptionally small. Yes, lithium plus is smaller, we can consider that. And the fourth one, all alkali metals give blue solution in liquid ammonia. Yes, all the alkali metals soluble in liquid ammonia producing what blue colored solution. That is their specific property of alkali metals. But option 2 you take, sodium is amphoteric in nature, is it? How can it be? Alkali metals are strongly basic in nature, but the given as what sodium is amphoteric in nature, that is the false statement among the given options. So question number 1 answer is 2. Coming to question number 2, sodium thiosulfate is formed when NaOH is neutralized by sulfuric acid. No, NaOH and sulfuric acid react, you are getting sodium sulfate, no choice. And option 2, Na2S boiled with sulfur, you are not getting any Na2S on boiling with sulfur, you are not getting any sodium thiosulfate. Coming to option 3, Na2SO3 is boiled with Na2S and I2. And option 4, Na2SO4 is boiled with Na2S. Option 3 you see, Na2SO3 boiled with Na2S and I2. This particular is commonly known as Springs reaction. What is Springs reaction? Heating the mixture containing sodium sulfite, iodine and sodium sulfite. This particular mixture on heating, you will be getting what? Sodium thiosulfate. How you get the sodium thiosulfate? Check it. Sodium sulfite, right, Na2SO3 plus iodine plus Na2S. This particular 2 NaI on heating this particular, then you are getting the product. This particular product you are getting Na2S2O3. So this particular Springs reaction represents the boiling or the heating the mixture containing Na2SO3 and iodine and Na2S. So here question number 2, this sodium sulfite is boiled with Na2S and I2. That is the correct answer. For the question number 2, answer is 3. Question number 3, sodium forms Na plus and not Na plus 2 because what are the options given? Check it. Sodium contains only one electron in outermost shell. Second, first ionization potential is small and the difference in first and second ionization potential is large. And third one, radius of Na plus 2 is much smaller than that of Na plus. And none of this. Sodium forms only Na plus. All the first A group of elements are forming only unipositive cations. Na easily forms Na plus because first A group, the general electronic configuration is not 1s1. They can lose only first electron easily, but the losing of second electron is very difficult as the first IP to second IP. First IP to second IP, a large difference is there. First IP to second IP, large difference is there. After losing one electron, all the first A group of elements are gaining stable noble gas configuration. Therefore, losing of second electron is very, very difficult. That is the option number 2. You see, first ionization potential is small and the difference in first ionization potential and second ionization potential is very large. Therefore, for the question number 3, that second answer 2 is correct. Coming to question number 4. Question number 4. Sodium bonds in 8 to give. Suppose generally what option is given? Option number 1 Na2O. Option number 2 Na2O2 and 3 NaO2 and fourth option Na3N. Na3N. Now sodium bond burning in 8. Yes, we agree. Na2O can be produced. But on burning at little higher temperature, Na plus O2 to Na 4Na plus stick 4Na plus O2 you are getting on burning, yes, to Na2O. On burning air, then this particular Na2O may be easily convertible into sodium peroxide. Take 2Na plus O2 near about 300 degrees centigrade, burning in air, then there is a possibility of getting Na2O2 at higher temperature. Higher temperature burning in air, then there is a possibility of getting what? Na2O2. So far, sodium burns in air to give sodium peroxide, the main product. Therefore, answer is 2. Question number 5, KO2, potassium superoxide, is used in oxygen cylinder in spacecraft and submarines because it. Option A is given as absorbs CO2 and increases O2 content. Absorbs CO2 and increases O2 content. Second, eliminate moisture. Third, absorbs CO2 only. And fourth, produces O3. Now you see, whenever KO2 actually reacting with what CO2, producing what O2 content, increasing the O2 content. How? Take here potassium superoxide, KO2 plus CO2 gives rise to, you are getting K2CO3, take here 4KO2, 2K2CO3 balance it, 2K2CO3, then you are getting what? 2O2. Like this, potassium superoxide reacts with CO2 producing potassium carbonate, and again you are getting oxygen. So it removes carbon dioxide and increases the oxygen content. So for the fifth question, answer is 1. Right, question number 6. When KCl is heated with constant sulfuric acid and solid K2Cr2O7. This particular mixture represents chromyl chloride test. Options are given as what? One is chromyl chloride, second one is chromous chloride, third is chromic chloride, fourth is chromic oxide. So this particular reaction mixture, this particular reaction represents chromyl chloride test, which is used as a confirmation test for the chloride ion in the laboratory. Now, K2Cr2O7 plus sulfuric acid acidified plus consider 4KCl. The products are actually 2CrO2Cl2, 2CrO2Cl2. This is what chromyl chloride plus you are getting 3K2SO4 and 3H2O. Potassium dichromate, acidified potassium dichromate, when reacts with what any chloride salt, produces a red fumes of chromyl chloride. Red fumes of chromyl chloride is one of the important confirmation tests for chloride ion. So option 1 is the correct answer here. Chromyl chloride is produced. Answer 1. Coming to question number 7. Question number 7. For alkali metal, which one of the following trends is incorrect? What is the incorrect trend? Let us see. Option 1. Hydration energy. Yes, lithium is very small, therefore its heat of hydration is very high. Lithium plus, Na plus, K plus, Rb plus, Cm plus. That's okay, correct. Coming to second, ionization energy. Lithium is smaller in size. Lithium is more than sodium. Sodium is more than potassium. Potassium is more than rubidium. Top to the bottom it is decreasing. Yes. Coming to third option, density. Lithium is less than sodium. Sodium is less than potassium. Potassium is less than rubidium is given. And coming to atomic size, lithium is what? Less than sodium. Potassium, rubidium is given. Yes. Atomic size also from top to the bottom it is increasing. But coming to the option 3, density from, suppose you consider lithium, sodium, potassium and rubidium you take. Top to the bottom density is increasing, we agree, but sodium to potassium density decrease. Density decrease. Why decrease? In potassium there is vacant d orbitals. Due to appearance of this vacant d orbitals in potassium, sodium to potassium density is decreasing. Therefore, the trend should be compulsory. Lithium is less than potassium, potassium is less than sodium, sodium is less than rubidium. This should be the trend. So, question number 7, option 3, density is actually the trend is not correct. So, answer is 3. Question number 8, which liberates SO2 with dilute sulfuric acid. SO2 with dilute sulfuric acid. Option A is Na2SO4. Na2SO4 sulfuric acid, you will not get any sulfur dioxide. Coming to NaHSO4. NaHSO4 and sulfuric acid, there is no reaction. If the reaction is there, it is not liberating SO2. But coming to option 3, Na2SO3 and sulfuric acid. Fourth option is about Na2S and sulfuric acid. Now, consider option 3. Na2SO3 plus sulfuric acid, getting Na2SO4 plus SO2 plus H2 are getting. Na2SO3 giving rise to what? Na2SO3 plus sulfuric acid, Na2SO4 and sulfur dioxide in H2. This is the reaction. So, question number 8, answer is 3. Question number 9. The color of iodine solution is discharged by shaking it with the aqueous solution of option 1 sulfuric acid, option 2 sodium sulfide, option 3 sodium sulfate and option 4 sodium thiosulfate. Generally, iodine is actually estimated by iodometric titration. Iodine is generally estimated by titrating against sodium thiosulfate. Now we see reaction between iodine and sodium thiosulfate. Na2S2O3 giving rise to 2NaI plus Na2S4O6. This is the reaction. Whenever iodine titrated against sodium thiosulfate, this iodine is what getting decolorized. Iodine is getting decolorized due to conversion of I2 to I minus ions. Due to conversion of I2 to I minus ions, the color is, the solution is actually getting decolorized. Once you are using this particular solution, iodine solution is actually added with what? Starch indicator, then the blue is the color. Here the blue color solution with starch, whenever titrated against sodium thiosulfate, it is converting into sodium iodide. When I2 converting into I minus, there will be change in the color or decolorization takes place. Therefore, iodine is actually estimated by titrating against sodium thiosulfate. So, iodine decolorizes in this particular reaction. So, 9th question, answer is 4, sodium thiosulfate. Question number 10. Sodium peroxide in contact with moist air turns white due to formation of, see, Na2O. Sodium peroxide with moisture is not producing any sodium monoxide. And coming to Na2S2O3, second option is given as Na2S2O3. Sodium peroxide with moisture is not converting any Na2S2O3. There is no choice of giving rise to any Na2S2O3. Coming to sodium bicarbonate, no. Coming to option 4, NaOH. Sodium peroxide in contact with the moist air turns white due to formation of sodium hydroxide. See the reaction. Na2O2 plus H2O, you are getting here 4NaOH plus O2. 4NaOH plus O2. Since Na2O2 converting into NaOH, therefore this pale yellow in color actually it is converting into white because of formation of NaOH. The 10th question answer is what? Fourth, that is what? NaOH. Answer is fourth. Coming to question number 11. Question number 11. A colorless salt colors a Bunsen flame golden yellow and also turns moistened litmus paper blue. This substance is. It is actually giving a golden yellow color in the Bunsen flame. We can simply say it's what? Sodium salt. Sodium only gives golden yellow color over the Bunsen flame. So given as what? Na2CO3, second is what? NaCl, third copper hydroxide, cupric hydroxide, and fourth K2CO3. Coming to option number 3, copper is given. It won't give any flame test like golden yellow. Coming to option 4, K2CO3, potassium is not giving this golden yellow color in the flame test. It gives only violet color or lilac color. Now coming to option 1, Na2CO3, option 2 is what? NaCl. But we have to choose, both are actually sodium compounds. Which is the correct option? You have to check it. And what is given? Colorless salt turns Bunsen flame golden yellow. Na2CO3 and NaCl both are carrying sodium metals. Both there is a choice of giving what? Golden yellow color. But next is there, and also turns moistened litmus paper blue. This particular sodium chloride solution is what? Neutral. It will not change. Sodium chloride solution or sodium chloride is neutral in nature. It won't change the color of the litmus paper. Only sodium carbonate. Sodium carbonate, whenever you are putting into water, sodium carbonate plus water, the resulting solution is what? Alkaline. Alkaline solution we are getting, so that Na2CO3 with moist air or moistened, then you are getting what? A basic property or basic solution you are getting. Therefore, option 1 is the correct, giving the golden yellow color, and also with moist air it is producing what? Basic substance or basic solution. Therefore, here answer is 1. Coming to question number 12. Select the incorrect statement about lithium. Let us see what is incorrect about lithium. First option, lithium metal is not affected by air. That's okay, it's not easily affected by air like other elements. When burnt in oxygen, lithium metal forms superoxide. Look here, lithium is very small in size, smaller atomic size. It generally produces only monoxide, not producing any peroxide, not producing any superoxide. When burnt in oxygen, lithium metal forms superoxide is given. Next, coming to option 3, lithium combines with nitrogen directly to form lithium nitrate. Remember, among all the alkali metals, lithium freely reacts with nitrogen or atmospheric nitrogen, produce lithium nitride. Coming to option 4, lithium has great tendency to form hydrates. Yes, lithium is very smaller ion. Lithium plus is smaller, greater charge density. It can easily hold the water molecules by electrostatic force. Therefore, lithium can also easily form hydrates. Coming to option 2, when burnt in oxygen, lithium metal forms superoxide. There is no possibility of formation of any superoxide by lithium because it is very small in size. Therefore, question number 12, option 2 is wrong. Therefore, what I can say, answer is 2. Question number 13. Question number 13. Which the following is known as a fusion mixture? With some of the trivial names, some of the names of the mixtures you have to remember. In this, what is the question is? Fusion mixture. Which combination we call it as what? Fusion mixture. Coming to a mixture of Na2CO3 and NaHCO3. It is not called as actually fusion mixture. Coming to Na2CO3 10H2O. Yes, Na2CO3 10H2O is known as washing powder, no, or sodium carbonate. Washing soda we call. Coming to mixture of K2CO3, Na2CO3, and fourth one C, NaHCO3. NaHCO3 well known to you, it is baking soda, and Na2CO3 10H2O you know, that is washing soda. Mixture of Na2CO3 NaHCO3, that is not having any particular name for that. Coming to option 3, K2CO3 and Na2CO3, this particular combination mixture, we call it what? A fusion mixture. What is the importance of fusion mixture? Whenever this particular mixture is added to any other substance, the melting point of the particular substance will be little bit decreased. So this particular K2CO3, Na2CO3, this mixture is known what? Fusion mixture. Therefore, question number 13, answer is 3. Coming to question number 14. Question number 14. Combustible gas is liberated when caustic soda is treated with. One is caustic soda. Caustic soda means sodium hydroxide. Sodium hydroxide on reaction with sulfur. Sodium hydroxide on reaction with sulfur, you are not getting any this particular, you are getting what? Sodium sulfide you are getting. Next, coming to ammonium chloride. Sodium hydroxide and ammonium chloride. Sodium hydroxide and ammonium chloride. Take sodium hydroxide plus sulfur. There is a possibility of formation of Na2S. Na2S. And this particular sodium hydroxide and ammonium salt, ammonium chloride. Then the possibility of getting only ammonia gas. Coming to sodium hydroxide and iodine. Sodium hydroxide and iodine, there is a formation of possibility of formation of, let us consider NaOI. This is the possibility. And zinc metal is given. Consider this sodium hydroxide plus zinc metal you take, then you are getting sodium zincate, Na2 ZnO2, Na2ZnO2 plus H2 gas you are getting, H2 gas, Na2ZnO2 plus H2 gas. This particular H2 gas is what? Combustible in nature. Therefore, a combustible gas is liberated when caustic soda solution is heated with only zinc metal. So, for question number 14, answer is 4. Next, question number 15. Microcosmic salt is. Which of the following is actually microcosmic salt? There's some of the chemical formula you have to remember. The trivial names, the other names. Just now we got a question to the following fusion mixture. Like that. What combination we call the fusion mixture? And different salts are there. Their common names also there. Such names, such chemical formula you have to remember. Microcosmic salt is actually sodium, ammonium, hydrogen phosphate. Sodium, ammonium, hydrogen phosphate. It is Na, NH4, HPO4, 4H2O. This is what a microcosmic salt. Therefore, for question number 15, answer is 1. Question number 16. Which of the following has the highest melting point? See, whenever a question is coming on a highest melting point, the melting point C. The molecular weight is more, we can say the melting point is more. Otherwise, how to say which is more ionic, you see. Among the given alkali metal salts are given, one is NaCl, NaF, NaBr, NaI. Among this particular, all the 4 salts, the more ionic is what? NaF. Lattice energy is more between the sodium plus and F minus ions. Therefore, among all the given options, NaF is having high melting point because ionic nature, you see, high lattice energy. Therefore, for question number 16, answer is 2. Question number 17. Clearly read the question and check what is the actual concept in that. When a substance A reacts with water, it produces a combustible gas B. Substance A reacting with water, producing a combustible gas B. And a solution of substance that is C you are getting in water. When another substance D reacts with this particular solution of C, it also produces the same gas B. Whatever the gas you are getting in the B, the first step, the second step also are getting the same gas B. Even on reaction with dilute sulfuric acid at room temperature, the same B gas you are getting, that was C on reaction with a metal you are getting gas B. The same metal with sulfuric acid also getting the same gas B. Next, A imparts a golden yellow color to the smokeless flame. See, a metal is giving golden yellow color. You have to strike it first Once a metal is giving a golden yellow colored flame or the Bunsen flame, then definitely you can say that golden yellow means sodium metal. Then you can conclude substance A is definitely sodium metal. Sodium metal reacting with water. This is the concept here. Sodium metal reacting with water. So Na reacting with water, then you are getting NaOH plus H2 gas. Consider 2Na plus 2H2 you take, that 2NaOH H2 gas. This particular B you take, this is what C solution. What is the E? When a substance A reacts with water, produces a combustible gas B, and solution of substance A. Solution of substance A, this is what C. This A react with water, producing what? Combustible gas B, and also solution C. Read the next sentence. When another substance D reacts with this solution C, also produces same gas B. Now C we are taking NaOH, and consider zinc. This is C. What is given? Another substance D is said. Consider this is part D. Then whenever zinc reacts with the caustic soda, then you can take Na2, ZnO2 plus H2 gas you are getting. Na2, ZnO2 plus H2 gas, the same combustible gas B you are getting again. See what? Read it. When a substance A reacts with water, producing combustible gas B and solution C. This solution C on reaction with another substance D, you are getting the same combustible gas B said. Combustible gas. Even on reaction with dilute sulfuric acid at room temperature, this particular sulfuric acid will take dilute sulfuric acid is saying, okay, dilute sulfuric acid, and this particular same zinc on reaction with this one, you are getting what? Zinc sulfate, again you are getting the same H2, which is combustible gas. Next, A imports golden yellow color, therefore A must and should be what? Sodium. Then what are A, B, C, D respectively? A is what? Sodium metal, B is what? Hydrogen gas, and C is what? Sodium hydroxide, and D is what? Zinc metal. So let us check the answers now. A is sodium metal, B is hydrogen gas, and C is sodium hydroxide, D is zinc metal. So for the question number 17, answer is 1. Coming to question number 18. In Solvay process of manufacture of sodium carbonate, the byproducts are. First, you should know what is actually Solvay process, what are the steps involved, what are the raw materials, and what are the byproducts, etc. What are the steps involved in this? First, we are taking ammonia gas, water plus CO2. By this, you are getting ammonium bicarbonate. You are getting. First, you are getting ammonium bicarbonate. First step this is. Ammonium bicarbonate made to react with brine, sodium chloride, then you are getting sodium bicarbonate. Sodium bicarbonate followed by ammonium chloride. First you are getting ammonium bicarbonate, second ammonium bicarbonate made to react with sodium chloride, then you are getting sodium bicarbonate. Third step. Sodium bicarbonate on igniting, on strong heating. Sodium bicarbonate you take, ignite on strong heating, then you are getting sodium carbonate plus CO2 plus H2O. These are the actual steps involved in the manufacture of sodium carbonate in a commercial way by Solvay process. What it is asking is actually the byproducts are. This particular ammonium chloride on reaction with calcium hydroxide, ammonium chloride on reaction with the calcium hydroxide, then you are getting ammonia gas. Take 2 times calcium chloride and NH3 2NH3 plus H2O. Take a 2H2O. So, what are actually byproducts? Byproducts is calcium chloride is the byproduct, and again ammonia is the byproduct. Here CO2 is also the byproduct. These are the important byproducts in this. So, 18 option A, ammonium chloride CaO is given. Next, calcium oxide Na2CO3 is given. Na2CO3 is the main product we are getting, not the byproduct. Coming to option 3, CaCl2, CO2 and NH3. See, CaCl2, NH3, CO2. These three are the important byproducts in the Solvay process. Therefore, for question number 18, answer is 3. Answer is 3. Next, coming to question number 19. Question number 19. Sodium is heated in air at 300 degrees centigrade, forms X. X absorbs CO2 to form Na2CO3 and Y. Which of the following is Y? Which of the following is Y? Sodium on heated to 300 degrees centigrade in presence of air is saying, right? Na plus O2. 2Na plus O2, 300 degrees centigrade, right? You are getting sodium peroxide. You are getting sodium peroxide. Sodium peroxide on reaction with the absorbs CO2 is saying, right? Na2O2 plus CO2. Take 2 times this one. Then you are getting, it is Na2CO3. 2Na2CO3, balance it. Then next one is what? CO2. So 2Na2CO3 plus CO2. What is the question here? Sodium on heating to 300 degrees centigrade, sodium peroxide you are getting. This is what sodium peroxide form X. This is the X, right? X. X absorbs CO2. This particular X is absorbing CO2. CO2 giving rise to Y, giving rise to sodium carbonate, and again Y. This is sodium carbonate you are getting. What is the gas Y? Y is nothing but oxygen. So, for question number 19, the answer is 2. Coming to question number 20. Sodium sulfate is soluble in water. Sodium sulfate is soluble in water, but barium sulfate is sparingly soluble in, because solubility depends on 2 factors. Solubility inversely proportional to lattice energy, directly proportional to heat of hydration. Remember, solubility of a particular salt depend on these 2 factors. One is lattice energy, the other is what? Heat of hydration. Heat of hydration. Now, in the case of sodium sulfate is soluble in water, but barium sulfate is sparingly soluble. Now, sodium sulfate is soluble means its heat of hydration may be more in comparison to barium plus 2, because barium plus 2 is very big in size. Its heat of hydration is less in comparison to Na plus. Now, so what are the options given? The hydration energy of sodium sulfate is more than its lattice energy, while the lattice energy of barium sulfate is more than the hydration energy. Means what we can say? The heat of hydration of sodium plus is more than heat of hydration of barium plus 2. Coming to second option, the lattice energy has no role. Okay, leave it. Coming to the lattice energy of sodium sulfate is more than its hydration energy. Once lattice energy is more, then it will not be soluble. But question is that sodium sulfate is soluble. Therefore, what we can consider? Option number 1, hydration energy of sodium sulfate is more than its lattice energy, while the lattice energy of barium sulfate is more than hydration energy. What we can conclude is heat of hydration of Na plus ion is more than heat of hydration of barium plus 2. When the heat of hydration is dominating the lattice energy, then that particular salt is soluble. Therefore, sodium sulfate is more soluble in comparison to barium sulfate. For this 20th question, the correct option is what? Answer 1. Coming to question number 21. The pair of compounds which cannot exist together. How you decide a pair of compounds are not existing together? Both are the bases. They won't react, they exist together. both are the acids, they won't react together, they exist together. But you see NaHCO3 and NaOH, option 1. Coming to NaHCO3 and NaOH, this is what? NaHCO3 what? Acidic salt little bit, but it's what? Basic. Acidic salt, and that is basic. Na2CO3 and NaHCO3 both are bases. Next, Na2CO3 and NaOH both are bases. And the fourth one, NaHCO3 and NaCl. NaHCO3 and NaCl. This is what? NaHCO3 acidic salt, we agree, but in the case of NaCl, the neutral. One neutral will not react with what? Acid. But in the case of the first one, NaHCO3 and NaOH. This is what? NaHCO3 is acidic salt, and again NaOH is what? Completely base. Therefore, they two, that the possibility of reaction between them, therefore those two will not exist together, they react together. Therefore, for question number 21, answer is 1. Coming to question number 22, a moderately concentrated solution of an alkali metal in NH3, pick the odd one out. So actually metal liquid ammonia solutions, alkali metal put into liquid ammonia solvent, this solution you are getting. So among the given options you have to see which is not correct in this. Pick the odd one out. Now, blue colored solution. Remember all the alkali metals whenever put into liquid ammonia, yes, producing blue colored solution. Coming to, it is paramagnetic. Yes, all the metal liquid ammonia solutions are generally found to be paramagnetic. Is a good conductor of electricity and its conductivity increases with increase in temperature. We agree. All the metal liquid ammonia solutions are good conductors. But it's added one thing there. By increasing the temperature, the electrical conductivity increasing is said. By increasing the temperature, the electrical conductivity of this particular solution is actually decreasing. But he said here increasing. By increasing the temperature, the conductivity increases, he is saying. Coming to option 4, the metastable. It is metastable also. But third option you see, it is a good conductor, we agree. But whenever temperature is increased, the conductivity of this particular solution is decreasing but not increasing. So for question number 22, answer is 3 only. Coming to question number 23, which of the following is not a white crystalline solid? Not a white crystalline solid. See NaHCO, suppose come to lithium bicarbonate. Look here, among all the first A group bicarbonate, lithium bicarbonate is only existing liquid state, remaining all are solids. First A group bicarbonates, lithium bicarbonate is only existing in the liquid state, remaining all are actually solids because lithium bicarbonate is highly covalent. Coming to option 2, NaHCO3 well known to you, with baking soda it is a solid. Next, white crystalline solid. Coming to KHCO3, yes, KHCO3 is also actually the solid. Next, coming to cesium bicarbonate, potassium bicarbonate, right? These are all actually existing in what? White crystalline solids or solid state. Only the lithium bicarbonate, look here and remember, lithium bicarbonate exists in the liquid state. Therefore, for question number 23, answer is 1. Coming to question number 24. Rubidium ICl2 on heating gives. Option 1, RbCl plus ICl, 2Rb plus 2Cl2 plus I2. Option 3, RbI plus Cl2. Option 4, 2RbICl plus Cl2. See, generally, if you talk about this particular interhalogen complexes, when a alkali metal halide reacts with interhalogen, then you are getting what? A complex compound. This particular complex, what is given? RbICl2. This is the complex. How you got it? This is actually RbCl on reaction with ICl. So, alkali metal halide on reaction with the interhalogen, you are getting the complex. What complex? RbICl2. Whenever this particular decomposed, you are getting back the same reactants you are getting. Rb, ICl2, you are heating this one, you are getting what? RbCl and ICl. Remember this particular complex, so it is actually alkali metal halide reaction with the interhalogen producing a complex. This particular complex on heating, you are getting the same reactants. Therefore, RbICl2 on heating you are getting RbCl plus ICl. Therefore, among the given options, RbCl plus ICl is the answer. Therefore, 24 answer is 1. Coming to question number 25. Sodium nitrate decomposes above 800 to give. So you have to remember the decomposition of a first A group of nitrates. Lithium nitrate decomposition is different from the decomposition of the nitrates of the same group. But sodium nitrate is asking about sodium nitrate. Sodium nitrate on heating, it is actually producing sodium nitrite and oxygen. This is the products. These are the products. Now, coming to the options, N2 gas, O2 gas, and NO2 gas, and Na2O. Sodium nitrate on decomposition, we are getting sodium nitrite and oxygen. So, answer 2 is the correct here. Answer 2. Question number 26. Which of the following compound does not produce carbon dioxide with sodium carbonate? Take the first one, Na2CO3 with SO2. Then we are getting what? Na2SO3 plus CO2. This SO2 on reacts with sodium carbonate. Yes, you are getting carbon dioxide. Coming to second, Na2CO3 on reaction with aqueous MgCl2. This is the reaction Na2CO3 plus 2H2O MgCl2. Magnesium carbonate plus split. Magnesium hydroxide you are getting. CO2 gas you are getting. You are getting here CO2 gas. Here also CO2 gas you are getting. Next, coming to option 3, SiO2 is said, right? Na2CO3 plus SiO2. CO3 plus SiO2. You are getting what? Na2 SiO3 plus CO2. See, SO2 is giving CO2 and aqueous MgCl2 also giving CO2, and again sodium carbonate is silica also getting what? CO2. Coming to next one, this sodium carbonate plus liquid lime or lime water to take, then you are getting here 2NaOH plus 2NaOH plus, then you are getting this calcium carbonate plus split you are getting. But here there is no choice of getting any carbon dioxide. Therefore, first reaction, second reaction, third reaction clearly you are observing. In all these cases you are getting carbon dioxide. But in the fourth, sodium carbonate on reaction with what? Lime water or calcium hydroxide, you are not getting any carbon dioxide. Therefore, for question number 26, answer is 4. Coming to question number 27. Question number 27. Which of the following statements is incorrect? Let us check what is the incorrect statement in the given. With water, Li3N liberates NH3. Yes, Li3N on hydrolysis produces NH3. Li3N plus 3H2O, then we are getting 3LiOH plus 2NH3. Okay, it's correct. Coming to, at high temperature, Li3N is decomposed to give lithium and nitrogen. Yes, Li3N on heated to very high temperature, then definitely decomposing to produce lithium and nitrogen also. Coming to the stability of peroxides or superoxides increases at the size of the metal ion increase. See, for the peroxides and superoxides, with the increase in the size of the metal, the superoxides and peroxides stability is increasing. That is also correct. Coming to the basic character of oxides of alkali metal decreases gradually. See, in the case of first A group of elements, either you take oxides or hydroxides from top to the bottom, their basicity increases. Either you take oxides or you take hydroxides, their basicity is increasing. But in this, they given as what? Decreasing. So for question number 27, answer is 4. Next, question number 28. Question number 28. Which of the following is the incorrect statement? Again, let us see which is the incorrect statement. 1. Glauber salt is Na2SO4 10H2O. Yes, sodium sulfate 10H2O is generally known as what? Glauber salt. For that I said, you have to remember some of the common names of different salts. Many are there, but you have to remember to answer this type of questions. Remember, sodium sulfate 10H2O, common known as Glauber salt. Coming to second, Li3PO4 is most insoluble salt of lithium. Insoluble salt of lithium. Yes, Li3PO4, the more covalent. Li3PO4 is covalent in nature. Therefore, this particular salt is most insoluble, very less soluble among the lithium salts. Li3PO4 is covalent, less soluble. Coming to next, like magnesium metal, lithium is ductile. Lithium is ductile. Magnesium metal, lithium is ductile. So magnesium we can make thin wires and thin sheets. Similarly, lithium also you can make it. So like magnesium, lithium also ductile and malleable. Coming to lithium is softer than other alkali metal. This is not correct. Among the alkali metals, lithium is little hard. Lithium is little hard. But what is given is lithium is softer than is given. That is not correct. Lithium is actually harder than all the metals of first year group of elements. So for question number 28, answer is 4. Coming to question number 29. Which of the following does not form peroxides on heating in air? See, sodium. Sodium on heating in air, it will easily form peroxides. Coming to barium, barium is bigger. Again, barium also easily forms. Calcium also easily forms. But lithium is very small in size. Whenever the atomic size of the metal is very small, the possibility of formation of peroxide is difficult. Therefore, among the first year and second year group of elements in general, if you talk about, lithium cannot easily form the peroxide. Therefore, for question number 29, answer is 4. Next, question number 30. Question number 30. The product formed when CO2 is bubbled into aqueous solution of sodium carbonate. So generally, whenever you are bubbling carbon dioxide into aqueous solution of sodium carbonate, the resultant product is what? Sodium bicarbonate. See, sodium carbonate, aqueous solution into this, we're passing CO2, the product is what? Sodium bicarbonate. Sodium bicarbonate is formed. So coming to option A, H2O is said. Bubbled into aqueous solution, sodium carbonate, the product form H2O, and option 2 is sodium bicarbonate. Option C is option 3rd, KNO3. Option 4, none of these. Sodium carbonate aqueous solution, you are bubbling CO2, the main product, only the product produced is what? Sodium bicarbonate. So here question number 30, answer is 2.